Hey there guys and gals, it's me nirex and welcome back to Beginner C++ Programming. So in this video we're going to talk a little bit about dynamic memory allocation in general, and well, that's just a topic, and in that topic we're going to explain all of these guys right here, all this bullshit. So we have an exception of which is stack overflow. It's an exception, kind of an error, kind of a thing that causes your program to crash. Let's just call it the exception just for now. We're going to talk about the memory type stack, heap, the keyword new, delete, memory leakage problem, and the concept of RAII. Well, not really the RAII concept, but a smaller concept that RAII follows. Alright, so this concept is based on another concept. We're going to follow that guy right there. Okay, now let's get right into the code and see what the hell everything is up about. So I have an array right here, right? Character R, which is equal to, the size of it is this much, all right? 1.03 megabytes. All right, if one of these guys is a byte, that's 1 million and this much, 30,000 megabytes. So I can put this much guys, this many bytes in an array right here, as you can see. So I've just created an array. If I run it, it's all okay, all dandy. I hit enter, everything is fine and good and dandy. Now let's say I have another LAN. Let's say I have max and I have 2 megabytes instead of 1. Alright, let's see what happens if I try to do something like that. If I want an array with this many elements in it. If I try to do that, my program just breaks out of everything, okay? It just goes messy. Now let's take a look at the message that it's giving me. So, unhandled exception at whatever in NX. Stack overflow, as you can see right here. Stack overflow, parameter, whatever and whatever. So, this guy right here is the type of exception that has been thrown. Alright, so exception, we throw exceptions, whatever. So, this is the type of exception that has been thrown. But what does this mean? What does stack overflow mean? Let's go here and I will tell you exactly what it means. So, your memory has a couple of parts, okay? There are 2 main parts and a kind of a dynamic part that is allocated for each and every program that exists. So the first one that we do care about is the stack. I'm not quite sure if the setting is like that. I'm sorry, yeah, this is static memory, I think. I'm not entirely sure about the placement, or if static is here or is here. So, correct me if I'm wrong. So we have the static memory here, we have a stack here, and we have a heap here. Alright, they're almost the same size, alright, maybe just 1 byte or 2. So that's basically it. Now stack is for each program, so every program has its own stack memory, right? When you run a program, for instance, let me just change the color, it occupies this much, alright? And it has its own stack and, its own share of static and heap memories, alright? So this guy is there and this guy is right here. So same thing here. So we have a stack for the program and we have all that good stuff, all around the place. So stack is not really a section of the RAM, it's just a section of your program. So it's not really, it is a section of RAM, of course, but it's dynamically allocated for your program. But we're going to talk about what dynamic is in just a second. It is something that any program has. Alright, so this guy right here, the sketchbook, has its own stack. The Notepad++ has its own stack. The Visual Studio has its own stack. When I run my program through Visual Studio, that program has its own stack. So every program has its own share of stack memory. Alright, and that's basically what stack is. Now, the good points about stack is that it's fast. It is it's basically what it is. It's just fast. Bad point is it's not dynamic and it's tiny. Alright, not even small, it's tiny. So as you can see, when I put this guy 1 megabyte, it's around a megabyte, okay? So you can determine how big your stack is for any program in the settings of your the properties of your project, you know, whenever you're compiling the shit. But by default, it's around this much. All right, if I put this to 4, it's gonna just mess up. So it is fast, it's not dynamic, we'll talk about this, and it's tiny, it's small, it's just about a megabyte. You can't really put anything in there. Alright? Now let's talk about Heap. So when I want to work with huge data, I can't really put them to stack when I want to bring them in RAM for fast computing and computation. I can't really do anything with stack. Stack is so small that it just can't hold that big of data. But it's fast. It's also not dynamic. So the solution is to use another type of memory called the heap. Alright? Now Heap is a bit different. It's also pretty fast, it is dynamic, and it's huge. It's almost half of your entire RAM is stack. I'm sorry, it's Heap. Alright, so it's super fast, it's dynamic, and it's huge. They're both equally fast. Maybe stack is a bit faster, but it doesn't matter. So these guys are, you know, the different types of memory that we care about. There is also the static memory, but we don't give a damn about static memory just yet. We will talk about it in the advanced series, not just yet. You know, just leave it out of here just for now. Just don't even think about it. It doesn't exist for now. We have these two types to care about. So we have stack and heap. Stack is fast. Heap is also fast. Stack is tiny, heap is huge, stack is not dynamic, and heap is dynamic. That's basically what it is. But what do I mean about dynamic? So any program has a couple of sections during its entire lifetime, from being born, being coded, into being released and being ran by any end user. But we don't care about all of them, we just care about 2 of them, alright? So there are 2 timelines or 2 time periods in each program's lifetime that we care about. One of them is called compile time, and one of them is called runtime. Now this, as you can see here, is a runtime error. If I try to it compiles fine. If I Control Shift B, you can see that it's 1 succeeded. Alright? But if I try to run it, it gives me an unhandled exception. So this is a runtime exception. Alright? This is not a compile time exception. If I try to do something like that, if I try to run it, you can see that I have tons of errors right here. That is a compile time exception or compile time error. Alright? So we have compile time bullshit and runtime bullshit, alright? Some things happen in compile time, some things obviously happen in runtime, but memory allocation can happen in both of them. And we only care about memory allocation. So when talking about compile time, when talking about stack memory, everything should be known during this time. Okay? If I want to get an array of 10 elements, this 10 must be known during the compile time. It cannot go through runtime. So if I do something like that, max is obviously known during compile time, that's obviously why it's there. But if I do something like this, int I equals 0, and then do stdin into I, if I try to create an array with this many elements, it's just going to give me an error. Now the reason to that is, if I hover over it, expression must have a constant value. The value of variable I declared at line 17 cannot be used as a constant. Basically what it's saying is that the value must be known during the compile time. You can't really get the value in runtime and then expect me to create something static, create something in the stack memory with it. Doesn't work that way. Alright, so stack cannot be created during runtime. It just allocates it through the compile time, does whatever it wants with it. Long story short, we can't do this, but we must. Okay, I mean, it's not a must, but we can't do this, but we have to, alright? One way or another, we're going to reach a kind of an issue that we have to do something like this. For instance, let's say you want to calculate like the average grade of n students in a class. How do you do that? N students, it means we have to have an array of size n, but we don't really know n for compile time. I mean, in compile time. And if we do, even if we do know that in compile time, if that changes in some way, we have to rewrite our program from scratch, all right? Update that new n value, put that into our code. But that's all bullcrap, right? We have to have some way to do it during the runtime, and that is with the new keyword. So the way we do it is like this. We say char r equals new char, and whatever value we want to give it, like I. And as you can see, don't look at this just yet. As you can see, the error down on this guy right here is totally gone, right? But there's a new error. Now we need to take care of that. If you read the thing, it says a value of type char pointer cannot be used to initialize an entity of type char. So what it's saying basically is that this guy right here is evaluating into some sort of char pointer. And you can't really assign a char pointer into a character. So what we need here is obviously a char pointer. Now this might not seem super logical, but let me explain it to you in a good way. Alright? So as I've already explained in my deep intuition, in my deep intuition video, a pointer is either 4 or 8 bytes, right? 4 for 32-bit operating system, or operating systems, of course. And 8 is for 64 bits, right? Jesus, that bit. 64 bits. Alright, 4 bytes, 8 bytes, 32 bits. So this is as big as it gets. Just for the time being, this is as big as it gets. Now, whenever I create something like this, I'm trying to put it into Heap, right? But here's the thing. If I want to put something huge like this, like 2 megabytes in Heap, and then bring that entire 2 megabytes back into stack, that will be the same idiotic stupidity that we tried in the beginning of the video, right? So if I try to put something huge here in the stack, it's just gonna crash, right? But I can put something huge in the heap. I can put something as big as like half of the memory in Heap. I can't really put it here, it's gonna just mess things up. But what I can do is I can have a tiny 8 or 4 bytes in my stack memory, which is a pointer, that points to where this guy begins. Alright, so when I do that, if I do something like this, I'm just allocating 4 or 8 bytes, which is also known during the compile time, and then I'm just pushing that. I'm just pushing the first value of this guy right here into this guy right here. So I have access to this entire block of data, no matter how big it can be, and I can bring it in the stack little by little, use it all I want. All I need to have constantly in my stack is the pointer. And that's basically one of the biggest use cases of pointers that you're ever gonna see. It's with the new keyword, and it's all pretty good. So new keyword basically allocates value for you. Let me just go ahead and do like here. Allocates value, I said. Allocates memory from Heap. So you look at the computer, the program looks at the computer, says, yo dude, at the kernel says, yo dude, I need some memory. And the kernel is gonna look at you and say, alright, the operating system is going to say, okay, but you got to give it back, right? And you're going to say, yeah, okay, cool. So the way you give back the memory is with the delete keyword. And I should write them like this because they're tiny. So new allocates memory from Heap, delete deallocates memory. So you allocate memory you use that memory, and when you're done with the memory, you just put it back. Alright? You don't need it, you leave it back so other programs can use it as well. Don't be a greedy piece of shit. Always delete whatever you knew. So whenever I'm done with my array right here, so let's say I do sum up with R. Alright, I do some sort of operation with array after I declared it. Now I just delete R. Easy peasy lemon squeezy. Now you can delete like this, but doesn't really matter. It used to matter a lot, but not really. So basically for arrays you do things like that. For normal values like this, you do things like this, alright? That's basically the difference. Just saying it so that people don't call me an idiot for not saying it, alright? Not that big of a deal, but it's there to use. Anyhow, so that is how you do things. When you knew something, right here, you always delete it. When you get something from the heap, you definitely give it back to the heap, alright? Yo, heap, I want some, huge amount of memory. And OS says, yeah, cool. We're all cool with that, but you have to give it back to me, and you have to promise that you give it back, and you do that with delete. You always delete what you knew. Always, all the time. That's actually very important, okay? Super important that you delete what you knew. Now, here's the thing. If you don't do that, if you don't commit to your promise, an issue will occur. A problem will rise. The memory leakage issue or problem. So let's look at memory like some sort of milk pocket, like this. All right, so it's kind of like this. I'm trying to. It's pretty bad, I know, but just go with it. All right. I don't know. I've never seen a milk pocket that looks like this, but okay. So if you drop this guy right here, like this, milk will spill out all over the place. And you can't really do anything about that milk ever again. You just know it's there, but you can't really pick it up with your bare hands. Alright? So there's an issue there. Now, using a tool to pick this up will be some concept called garbage collection, but we don't give a damn about garbage collection. We only care about the entirety of this, the concept of this guy. So memory leakage is exactly like spilled milk. If you spill your milk, you don't ever have any access to that milk that's gone. You can't use it, it's just there, it's gonna stink, you know it's there, but you can't use it. Memory leakage is the exact same thing, but in the computer world. So let's say we have some memory here, alright? This is our heap memory. And this right here is our stack memory. Alright? So we have one tiny little guy right here that is pointing to an array right here, right? Now the way leakage happens is that if I don't delete this and then re-point this guy to some other dude, alright, so first this happens, and then this happens. I've newed this guy, and then I've newed this guy without deleting this guy. This guy has not been deleted, and then I delete my second guy. What's gonna happen is this guy is now lost in memory. What I mean by lost is that we don't have any sort of access to it ever again. If I lose the pointer to this guy, which I am losing, like this, then all is lost in memory. This guy is just going to be there like some sort of a zombie data. It's not going to be able to, you're not going to be able to access it. You're not going to be able to do anything with it. It's just messed up. All right, and that's why pointers are considered unsafe coding. And in C# we have a tag, or rather a scope, unsafe scope, where you can use pointers in C#. They really aren't there, but you can use pointers in C#. Anyways, we're not here to talk about C#. So memory leakage is pretty bad, alright? When this happens, the hugest shit hits the hugest fan, alright? Don't ever do that. Don't ever mess with this guy right here. I mean, the operating system is kind enough to us actually, to clean any sort of memory leakage after our application closes. So if I have tons of memory leakage, if I leak so much memory, shit, I can't even talk. When my program ends, it all automatically goes away, alright? But, yeah, let's not do that. Let's not even go there. So memory leakage, shit hitting the fan too hard. Alright, don't ever go here. The biggest shit hits the biggest fan. And the way it happens is exactly like that. So let's say R equals new character 10, for instance. Now, as you can see, I've newed it 2 times, but deleted it 1 time. If I even do this, it's not gonna work. This guy is still lost in memory. This guy is still there because the access to this guy is totally gone. Now let's talk about RAII. Not really. We're going to talk about the concept RAII follows and the standard I follow. So standard. Nirex is cool. Standard. Alright, so RAII, what it is resource acquisition is initialization, but we don't really give a damn about that. What we care is what this guy follows. So this guy says for each new there must be a delete. That's basically what it's saying. For each new there must be a delete. If you don't delete anything that's been newed, if you don't delete something that's been newed, then you're messing up, then you're fucking up. Because you have memory leakage, and that's bad as hell. But let's talk about my standard, which will help you in this concept of newing bullshit. So what I always say is that this guy is tiny. It's either 4 bytes or 8 bytes. Not that big of a deal. So best use a second pointer if you want to new a second array. So do something like this. Now you have 2 pointers pointing to 2 sections of memory, 2 different sections. And this is actually pretty good. And the reason to that is, well, you don't really make any mistakes when you do things this way, alright? So when you create something like this, the array number 1, this guy, this little variable right here, is always pointing to this section of memory, and this guy is always pointing to this section of memory. Do not ever retarget pointers if you don't have to. You can create empty pointers like that and then retarget them, so mtr, and you can do something like this. You can do something like mtr equals r1, but you don't retarget these pointers right here. And there's a thing we can do to make that happen, is put that guy right there, then this won't happen. We can also put something right here, and then you can't really retarget anything like that. I can really do something like this. Alright, if I put a const here, but you don't always have to. So yeah, basically what I'm saying is when you're creating something, you do things this way, alright? But then you can do whatever you want in this, and then do your operations here. So you can put that const there, but let's not talk about that. We're not here to talk about const. Const is going to be explained, what was it, right here. Alright, so don't worry about what I just said. You can do that, but let's not do that just yet. Just remember, do not retarget whatever that you initialize with the new keyword. Alright? Do not retarget these. You can do other good stuff like this, but do not retarget these guys. I'm pretty serious about this. It's actually not good to do that unless you're super careful, like you hold the value of this in some other place and then you retarget it and then do that. But I don't know, I don't think there's a huge amount of usage if you want to do something like that. Alright, just do something like this. Anyhow, that's been it for this video. If you have any questions or have any issues or problems or whatever suggestions, leave them in the comments below. If you enjoyed this video, do leave a like, and if you really enjoyed it, do subscribe. That would help a lot. And thank you very much. I will see you in the next one.